we can graph log base 2 of x now, even with our calculator. That's something we couldn't do before we had these 84s that had the log base function in them. So we were stuck with having to graph these by graphing the inverse and then switching all the points and then graphing those points. You don't have to do that anymore. You shouldn't, when you're doing the graph for homework, let's say, you shouldn't be showing both because you looked at the example and you couldn't figure out that you didn't have to do the exponential. You were being asked the graph of the logarithm. So just do the one you're being asked for. Okay. So let's go ahead and say, let's say that this is our f of x, right? F of x equals log base 2 of x. Because of what we learned on the last slide, what will be f minus 1 of x? 2 to the x. 2 to the x. Okay. So if we didn't have a calculator that we could plug in and create a table of values, we could at least do it for this. Right? So let's do that. Let's make a table of values for x and y. And I'll go -2, -1, 0, 1, and 2. I get to pick those, so I'm going to pick them. And then I'll plug in one at a time in for x here. So that's 2 to the -2, which is 1 over 2 squared, which is 1/4. All right, this is 2 to the -1, which is 1 over 2, which is a half. And this is 2 to the 0, which is 1, 2 to the 1, which is 2, and 2 squared, which is 4. Okay, now the inverse, those points should just be flipped. Now it's the y's that are -2, -1, 0, 1, and 2. And it's the x's that go from 1/4 to 1/2 to 1, 2, and 4. So if we graph these, do the exponential first. Right? It's an exponential growth. We know it has an asymptote here, which is y equals 0. I'm going to make this go 1, 2, 3, 4, 1, 2, 2, 3, 4, 1, 2. Okay, I'm graphing these from -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. If I connect those up, I get that. If I graph this set of points in blue, then I'm going to get 1/4 -2. So 1/4 -2, 1/2 -1, 1, 0, 2, 1, and 4, 2. 1, 2, 3, 4, 2. Connect them up. Okay, so what we learned about the graphs of inverses is they should look like they are reflections across the line y equals x. So I'm going to sketch in the line y equals x. I mean, it should be a mirror image. If you can tilt your head and just look, just that flips down there. So now, when we had the exponential had a y-intercept of 1, the logarithm is an x-intercept of 1. The exponential had a horizontal asymptote on the x-axis. The logarithm has a vertical asymptote on the y-axis. The exponential had a domain of all reals. It had a range of y greater than 0. Then the logarithm, because domains and range, just like x's and y's, switch. Right? the domain is x greater than 0, and the range is all reals. Right. So when you make an inverse, the domain of the function is the range of the inverse. The range of the function is the domain of the inverse. They switch just like the x's and the y's. Okay, and let's see. And this just brings up one more point. Up till now, when we were looking at domains, we knew we had to restrict the domain for two situations. No divide by 0, no square root or even root of a negative number. Now we have another one. You can't take the logarithm of 0 or negative numbers. You can only take logarithms of positive numbers, because that's what we learned from the graph here, right? It doesn't touch that axis, but it's never negative. Can't take the log of a negative number or 0.